Calculate the slope of the line containing the 2 points. So we're going to use our slope formula, which is this, y2 minus y1 over x2 minus x1. So we take our second y minus our first y, which is 2 minus 4. On the bottom, we're going to take our second x minus our first x, which is negative 6 minus negative 3. On the bottom, on the top, I get negative 2. On the bottom, I like to add the opposite there, so that gives me negative 3. Simplify that fraction. The only thing we can simplify is the fact that a negative divided by a negative is a positive. So slope is 2/3. Here we have a line in slope-intercept form, and they ask you what the slope and the y-intercept is. The slope is the multiplier of the x, so that's 2, and the y-intercept is the value getting added to the end. Well, what's getting added to the end is negative 9. Here they ask you what the x and y intercepts are. For the x-intercept, y equals 0. So I'm going to plug 0 in for y here and solve for x. So I'm going to subtract 5 and then divide by 10 to get x when y is 0. So x equals negative 1/2. So the x-intercept is negative 1/2. What is the y-intercept? Well, we could plug in 0 for x, but this is in slope-intercept form. You'll still get this at the right answer, but the y-intercept is just 5. That's the beauty of slope-intercept form. That intercept is specifically your y-intercept. Determine the equation of the line on the graph. Well, let's put this in slope-intercept form. So we want the slope and we want the y-intercept. So let's go find the y-intercept where the line crosses the y-axis. That's at negative 3. Let's calculate the slope. We have to go, so find another point that the graph clearly intersects. It's right there. We have to go up 1 and right 3. And the slope is rise over run. So it's 1/3 going in place of x. So y equals 1/3 x minus 3. If the line was going down in this direction, folks, down and to the right, it would be a negative slope. So you'd have a negative in front of your rise run fraction. Find the equation of the line described. A line that passes through this point, that's an x and a y, and is parallel to this line. This line has a slope of 2, and parallel lines have the same slope. So using this information, which is the information describing your new line, you can use this coordinate pair, the xy, and the slope to calculate the y-intercept. Because we know the slope of our new line, but we don't know the y-intercept. And no, we would be foolish to think that our y-intercept would be the exact same as the other line that we're parallel to. So there's 2 ways you can go about this. You can use point-slope form. That's y minus your y value equals slope times x minus your x value. And then you just simplify this by distributing and then solving for y. So we'd add 1 and add 1. And so we get y equals 2x minus 3. If you don't like that method, you could use slope-intercept form. Again, we don't know the y-intercept, so that's going to stay b. Your y value is 1, your slope value is 2, your x value is 2. So 1 equals 4 plus b. Now solve for b, your y-intercept. So subtract 4, you get b equals negative 3 again. So regardless, we know our slope is 2, so y equals 2x. And our y-intercept is 3, so minus 3. The line that passes through this point and has this slope, we're going to actually use the same skill that we just did. The previous one was a little more difficult, so they give us an x and a y, and they give us a slope. We just plug it into point-slope form or into slope-intercept form, whichever your style is. So we get y equals 2x plus 3. Point-slope form simplifies into slope-intercept form, or you can do it this way. Oops. Yeah, I'll write it down. Using slope-intercept form, plug in your y value, plug in your slope, plug in your x value, solve for b. You're going to be subtracting 2 because 2 times 1 is 2, so you get 3 is what b is. But then you take that and you take your slope and you write it in slope-intercept form, which would still be that answer. X and y vary directly when y is 9 and x is 12. What is the what is the equation relating x and y? So the thing to remember is essentially you could use what we just did, but what we're assuming or what we know when x and y vary directly is that your y-intercept is 0. So you're really looking for your slope. So we know that y is 9. We don't know what the slope is, although they usually use k here. So, and again, your y-intercept is 0. So you're solving for slope, which is m or k. So divide by 12 because there is no y-intercept. So m equals 9/12, which is written as 3/4. So what is the equation relating it? Well, y equals 3/4 x. And then you could write down the plus 0, but it's silly to do that. So this would be the equation. Graph the inequality. Remember to shade the graph. And by the way, folks, when we have one of these symbols, the line's going to be dashed. When we have an equal sign underneath it, it's a solid line. So y-intercept's -1. Slope is 3/4. So up 3, right 4, up 3, right 4, down 3, left 4, down 3, left 4. And then we are going to dash the line. And then to figure out which side of the line to shade, you could do a test point. You could test 0, 0. So plug in 0 for x and 0 for y and see if it's true. If it's true, and I should actually label my test point. There's the point I'm testing. If it's true, you're going to shade on the side of the point that you tested. So I get 0 is less than -1. Or you can ask yourself, is Pac-Man eating the correct number? It's not. No, so this is false. So no, this point right here is not a solution, nor is anything on this side of the line that the point was on. So that means my solution's over here. Number 23, we're going backwards. What is the equation of the graphed inequality? So I see it's a solid line. That's good to know. So I'm going to be thinking I'm using either this symbol or that symbol. And the y-intercept is 2. So b equals 2. Let's find our slope. Our slope, let's see, it connects right there. So I think that's 1/3. So we're thinking y something blank 1/3 x plus 2. Now they shaded above the line. That means that y is, what we're shading is where the y's are greater than or equal to the line. So we're going to shade that way. Otherwise, you could just see if you could just guess and then do a test point and see if it's correct. And if it's not correct, flip the way that your symbol is pointing. Ooh, piecewise functions. So this is where, if we were to graph this, I'm going to just sketch this. It's going to be super messy or super quick. This is where we have two different lines that come together. And maybe they actually touch, maybe they don't. Doesn't really matter right now for what we're talking about. Oops. So something like this. This function, the actual function f of x, is a combination of these two lines. And so the line to the right we use when x is greater than 4. The line to the left we use when x is less than or equal to 4. So they want to know what's the value of the function when x is 3. Remember, we write this f of x, so what's missing, or what they replace? They replace 3. They replace x with 3, so x equals 3 is what this is telling you. Well, which function do we use when x is 3? Well, 3 is less than or equal to 4, so we use this function. So to get our answer, we use the bottom one, and we plug 3 in for x. And when you do that, you get -9. So when x is 3, y is -9. Maybe I didn't scale my graph right, but I kind of told you I was just sketching it.